everybody. Today what we're going to be working on is adding and subtracting rational expressions. And if we can just remember how to add and subtract fractions with just regular old numbers, that's going to help us with how we are going to add and subtract rational expressions. So first of all, we're going to talk about adding and subtracting fractions that have common denominators. So just a reminder that what you do is you keep your denominator and you add your numerators. And then, of course, math teachers love when you reduce. So we're going to reduce this. So we divide by 2, and we get 3 over 4. Okay, subtracting is basically the same thing. If we have common denominators, we keep that denominator, we subtract our numerators, and then, yep, we want to reduce this. 4 and 12 are both divisible by 4, so we get 1/3. So far, so good, right? So the next thing, now we're going to extend this to rational expressions. So we say, do we have the same denominators? And in this case, we do. We have x plus 4. I happen to bundle it in the parentheses just to make a point that they're the same. So we keep the x plus 4, and we add the numerators. Now, when we add these numerators, we're going to combine the like terms. So we get 3x plus 12. Here's where it gets interesting. What we want to do is we want to see if we can factor out the numerator. So, I told you factoring never goes away. We have 3 and 12. We can take out the GCF of 3, which leaves us with x plus 4. And then our denominator is just a plain old x plus 4. You know what that means? That means now that we have the numerator as 3 times x plus 4, and the denominator is really just x plus 4, we can cancel out the x plus 4s. What we're left with? 3. Okay, so you go ahead and try the next one and see what you can do. Okay, I want you to pause this video, try the next one, and then turn the video back on, and let's see how you did. Okay, so hopefully you did okay. I just want to make a point that, I want you to know you can't always cancel out everything and just be left with, a number like this, a numeric answer. Sometimes you do have variables left over, but these two problems just happen to show that things canceled out and just left, in this case, the 3, in this case, the 5. Okay, so subtracting, kind of the same idea. What we do try to do, so in this case, we have 2x plus 14 and 2x plus 14, so they are the same. So I'm going to keep that 2x plus 14, and now I'm going to subtract x squared minus 49. So again, like we did before, we factor, 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 and to be honest, I normally would factor at the beginning, but because they were the same, I figured, let's just do it afterward. So when we factor the denominator, we get 2 times x plus 7. In our numerator, I hope you recognize that what we have there is the difference of squares. So we can factor that to be x plus 7 times x minus 7. That's good news because it looks like now that we have the numerator as this value times this value, and the denominator as 2 times this value, we can start canceling things out if they're exactly the same. So x plus 7 and x plus 7 can cancel out, and we are left with x minus 7 over 2. That's our final answer. The second problem, I know it says you try, but I'd like to do it with you because that subtraction, after the subtraction, we have a binomial up here. So my suggestion to you is that you turn this into addition and then distribute the negative to each term. Now you can go ahead and do what we just did on the previous problem, which is keep your 4a plus 1 and combine your terms in your numerator. So you have 12a and negative 4a, which gives us 8a. And then you have negative 3 plus 5, which gives us plus 2. Okay, so I think it's good to, when you have subtraction, that you put plus and you distribute that negative to everything in the numerator. At this point, we want to see if we can factor. So 8a and 2, we have a GCF of 2. So we can factor out the 2, which leaves us with 4a plus 1. And that denominator, can't do anything there. It's just 4a plus 1. But this is nice because we can cancel out the 4a's plus 1, and we're left with 2. Okay. Hopefully that made sense. The next problem, they kind of look like they have the same denominator, but not exactly. So when you see something like this, where you have b minus 9 and then 9 minus b, they're the same terms but the opposite signs. What we're going to do is we're going to factor out a negative 1 from one of these terms. Okay, so we can factor out a negative 1, which is going to make our 9 negative and our b positive. And I'm just going to turn this around. So I'm going to make it b minus 9. Now, this negative 1, we can keep it in the denominator, or we can kick it up to the numerator, which would change both of those signs. I'm going to do a little rewrite. The first fraction is unchanged, so it's 2 minus 5b over b minus 9. Plus, now I'm going to put the negative with the 4b, which makes it negative 4b, and negative with the minus 5, which makes that plus 5. Now that I have removed it from the denominator and I've put it to the numerator, I'm just left with b minus 9. So we have common denominators. So we're kind of back to what we did before. You keep that denominator, combine the common terms in the numerator. So we have negative 5b minus another 4b, which gives us negative 9b. And then we have 2 plus 5, which is 7. There's nothing we can factor out in the numerator. There's nothing we can factor out in the denominator. So that is our answer. Okay, so we can't always cancel things out. Let that sink in for a little while. Make sure you understand everything. And when you're ready, go to the next page. Okay, so it's about to get real, because now what we're going to do is we're going to add and subtract fractions that do not have common denominators. So let's recall, with numeric fractions, what we have to do is we have to get a common denominator. So we have to say, what element does this have that this fraction does not have? Well, it needs a 3 in the denominator. So we will multiply by 3 over 3. This fraction has a 7 in the denominator. This one does not. So we will multiply by 7 over 7. What that gives us is a least common denominator of 21. So we have 7 times 2, which is 14 over 21. And then we have 1 times 3, which is 3, also over 21. Now this problem is like what we did on the previous page. We keep the 21 and we add our numerators. Now we see if we can reduce. We can't reduce, so that's our answer. Let's check the next one. We have to say, what's the least common denominator of 4 and 5? Least common denominator is 20, or what's the least common multiple, right? So 4 times 5 is 20. That's the least common denominator. So we will multiply this by 4 over 4. We will multiply the first fraction by 5 over 5. That gives us denominators of 20. 5 times 1 is 5. This is a subtraction problem. We have a denominator of 20 here. 3 times 4 is 12. And again, you don't have to do it because it's only one term, but you're sort of thinking of 5 minus 12. You might, in your mind, think of that, but it's kind of like better if you don't write it out. Let's leave that denominator of 20. 5 minus 12 is negative 7. Reduce if you can. Can't reduce, so we keep that answer. So basically, if we don't have common denominators, we get common denominators. All right, so now we're going to extend this to rational expressions. We have to think about what we have in front of us. So we have x over x minus 4. Okay? In this case, we have x plus 4 over x plus 4. Now, we could simplify that, can't we? Let's pretend we can't. Okay, let's pretend we can't because I want to make a point of what we can do here. This denominator has x minus 4. The second denominator does not. So what we're going to do is we're going to multiply this by x minus 4 over x minus 4. The first fraction has x minus 4, but it needs the x plus 4. That's going to make it so they have common denominators. So we will multiply the first fraction by x plus 4 over x plus 4. Here's what this gives us. The first fraction will have the denominator x minus 4 times x plus 4. The second denominator will also have that. And I'm writing it out, but you'll find some efficiencies as we do these. I just want to write it all out and do the fractions separately. So it's important now that we get the right values here. We have to multiply these, what we have here, to make our first numerator. So we're essentially distributing the x in there, and what we get is x squared plus 4x. The second fraction we're going to FOIL, right? Now, if you notice, x plus 4x minus 4, so we get x squared minus 4x plus 4x. That actually cancels out. And then 4 times negative 4 is 16. Okay. Now, again, we look and we say, well, we have common denominators, so we can combine these numerators together. So I'm going to keep my denominator of x minus 4, x plus 4, and I'm now going to combine my numerators. So x squared plus x squared, 2x squared. Plus 4x can't be combined with the negative 16, so we leave that. Now, just like we talked about earlier, we want to see if we can factor. Factoring's not going away. The denominator's already factored, so that's good news. 2, 4, and negative 16 are all divisible by 2. So we will factor out the 2, which leaves us with x squared plus 2x minus 8. All divided by x minus 4, x plus 4. That didn't change. My computer's hesitating as I write. Okay. Can we factor this trinomial? Are there two numbers that multiply to equal negative 8 that would add to equal 2? There are. So we're going to keep the 2, and we should have 4 times negative 2. So x plus 4, x minus 2. And again, that's all over x minus 4, x plus 4. Okay, now that we have our fraction in factored form, we see if there are any common elements to the numerator and denominator. And in fact, there are the x plus 4 and the x plus 4. This leaves us with an answer of 2 times x minus 2, all divided by x minus 4. And that's our answer. Okay, so there's a lot there. So when we don't have a common denominator, we have to get a common denominator. Okay, what we usually have to do is we have to make sure we're in factored form first, which this was actually given to you. There was nothing to factor here. If we look at example 2, what you'll notice is nothing here can be factored, but a squared minus 4 is the difference of squares. So this is a plus 2, a minus 2. So if we look at our denominators, I'm going to erase the previous problem because I need some room over here. Okay, so if we look at this and we look at our denominators, what we can see is now this denominator has a plus 2a minus 2. This denominator only has a plus 2. So what is it missing? It's missing an a minus 2. So you must multiply the numerator and denominator by a minus 2. And then we have to multiply things out. Okay, so we don't multiply the denominator. We keep the denominator in factored form. So we keep that first denominator as a plus 2, a minus 2. But we have to figure out what all of this would multiply out to be. So a times a is a squared. A times 5 is 5a. Negative 2 times a is negative 2a. So I'm going to put that right down now as plus 3a. I can combine those terms. Negative 2 times 5 is negative 10. And then we have the other fraction, which is a plus 5 over a plus 2a minus 2. Okay, so it's at this point now that we say, all right, let's keep that denominator. We're going to keep our a plus 2a minus 2, and we're going to combine whatever like terms we have. So a squared, nothing to combine here. We leave it as a squared. 3a plus a is 4a. Negative 10 plus 5 gives us minus 5. Now, wouldn't it be nice if we were finished? But of course, now that we have a trinomial, now we have to see if we can factor. So are there two numbers that multiply to equal negative 5 that will add up to 4? And there are. Positive 5, negative 1. So we can factor our numerator to be a plus 5 times a minus 1, all divided by the same denominator that we've been carrying around for a while, right? A plus 2 times a minus 2. Can we cancel anything out? Absolutely not. No common elements, so that's our answer. Leave it in factored form. That's how we like it. Okay? It's a lot of work. Factoring, finding common denominators, combining like terms, factor again. Okay, but we can do this. Okay, subtraction. Very much the same deal, except remember what I told you on the previous page. I would turn this into plus a negative. Okay, So first thing we're going to do, we're going to factor out these denominators if we can. The first one we can factor. The second one we can't factor. So now we have to look and we have to say, what does this denominator have that this denominator does not have? Well, it's missing a 2. So we're going to multiply the numerator and denominator by 2. What we get, I'm going to leave the 3x minus 7 over 2 times x plus 5. That's really untouched other than the factoring. But then we have, and I have a plus here, negative 8 over 2 times x plus 5. And again, I'm not going to do anything with that. I'm just going to leave it. Let's combine our numerators. We're left with 3x, and we have negative 7 minus 8, which is minus 15, all divided by 2 times x plus 5. Okay, so now that we've combined our terms, now what we're going to do is we're going to see if we can factor. And if you look at that numerator, you can factor out the 3. You're left with x minus 5 over 2 times x plus 5. That's it. You're done. Nothing can be simplified there. So that's our answer. This is the end of the video. You do not have to do any more problems. When we come into class next, we will try to do these problems together. Okay? Have a wonderful day, everybody.